Alright, step number 3 is to rewrite the PDE in a finite difference form. Okay, rewrite the heat equation that is given to us in the problem with the finite difference form formula. Okay, so you are given the U sub t or del U del t equals to the 4 over pi square del square U del x square. Okay, and remember this is FTCS scheme. So we are using the forward difference to rewrite the derivative with respect to the time, and we are using the centered difference to rewrite the derivative, the second derivative with respect to the space x. Okay, so we are replacing del u del t with the uij plus 1 minus uij over k equals to the 4 over pi square uxx is ui minus 1j minus 2uij plus ui plus 1 j over h square. Okay, and the rule in the FTCS, okay, is to rearrange uij plus 1, okay, to be at the left side and bring the rest of the terms at the right hand side. Okay, because uij plus 1 later will be our reference node, okay, to determine our I and j value that need to be used in the next calculation later. So isolating uij plus 1, and the rest will be 4k over pi square, and I put the h square together with the fraction, and then in the bracket you have ui minus 1j minus 2uij plus ui plus 1j, and at the left you still have minus uij, so bring it to the right hand side so it becomes uij, and you can see we can simplify further. Uij here can be grouped together with this uij, and remember we have the coefficient, okay, at the outside of the bracket here, and also with the h that is given to us. H is 1, k equals 0.04, so we can simplify everything. So the final equation should be I give you the simplified value here in the form of decimal, so it should be, so after few steps here you should get 0.0162 ui minus 1j plus 0.9676 uij plus 0.0162 ui plus 1j, which can be represented as the molecule diagram. The coefficient 0.9676, this is uij, and on the right it should be 0.0162, the coefficient for the ui plus 1j, and on the left you have 0.0162 as the coefficient to the ui minus 1j, and at the top you have 1, which is the coefficient of uij plus 1. So the equation is uij plus 1 equals to the whatever coefficient ui minus 1j plus here and also plus. Okay, so that is the computational molecule correspond to the equation that you can see here. So this is the equation that you will be referring to later. Okay, that is step number 3. Alright, the last step is basically to straight away find our unknowns, find the unknowns. Okay, so based on the grid that you have sketched in step number 1, you can see all the unknowns is basically at the level t equals 0.04, which are u11, 21, 31, and another 3 is at the level t2, okay, 0.08. Okay, so this correspond to the question that is given to you. Find all the temperature value at T equals 0.04 and also T equals 0.08. Okay, so you have 3 here and another 3 at the top. Okay, so we'll start with the U11 first. Okay, finding the U11. So you can see just now from the computational molecule, you have one node here and the 3 nodes at the bottom, your computational molecule just now, where this is your UI j plus 1. Okay, so it means that if you want to know this guy, U11, okay, you map to this guy. Okay, so if you want to find the U11, so it depends on the 3 values here. Okay, for whatever coefficient that you have just now. So you have U11 equals to the 0.0162U00 plus 0.9676U10 plus 0.0162U20. Okay, so that's why it is called explicit scheme, because in order for you to get U11, you get the value straight away, because the 3 values that you are depending on are basically already the known value. Okay, similarly, later when you want to find U21, so it depends on these 3 nodes. Okay, which also already the known value. Similarly for the U31. Okay, and later at the second layer here, when you want to get the U12, it will depends on these 3. Okay, so prior to this, you actually already have all the values at the level 0.04. So it will be not a problem lah. Okay, because in order for you to get U12, you will need this 3 guys which you already have their values, okay, prior to that. Okay, so that is the relationship again between your computational molecule with the unknowns, okay, in your grid. Alright, so the first unknown is U11. Okay, so just now this is your U11, so it will depends on U00, U10 here and U20 with the coefficient value there lah. Okay, so this is one way by looking at the computational molecule, or without the computational molecule. So basically, if you want to get the U11, you can map to the UI j plus 1. This is another way. Okay, I think most of the students will just map to the UI j plus 1 without looking at the computational molecule. Okay, so you want to get U11 by mapping to the UI j plus 1. Okay, so your UI j plus 1 act as your reference node. Okay, so with that, you will know that your first value of I should be 1, j should be 0. Only when I equals 1, j equals to 0, you will get your U11. So at the left side, it is U11 equals. Okay, so basically you substitute I and j value in the equation in the box here. Okay, I equals 1, j equal to 0. So at the left, you have U11. And at the right, okay, it is equal to 0.0162 UI minus 1. So your I is 1, so I minus 1 is 0, j is 0. This is UI minus 1j plus 0.9676 Uij. So I is 1, j is 0 plus 0.0162 Ui plus 1. So your current I is 1, so it will be U sub 2, 0. So you can see all the values at the right hand side basically are known value. They are not your unknown. The unknown is only the value at the left here. So that's why at the first place, previously in the previous step, we isolate the Ui j plus 1 to be at the left side. Okay, so based on step number 2, you already have the value of U00, which is 0. So refer back to your step number 2, the boundary condition and also the initial condition. U10 is 1.207 and U20 is 1. Okay, and then just press your calculator to simplify. the value at the right hand side. Okay, plus minus and enter, you will get the value straight away, which is 1.1841. Okay, that is U11. So you have done U11. Similarly, for the U21, okay, you are now mapping to the Uij plus 1. Okay, so that you know that your I should be 2, J should be 0. Okay, so you basically have U21 equals to 0.0162 U10 plus 0.9676 U20 plus 0.0162 U30. All the values at the right should be known value. Just refer at step number 2. Okay, U10 is 1.207, U20 is 1, U30 just now is 0.207, and then simplify the value. U21 is 0.9905. Okay, so you have done with the U21. Similarly, you will get for U31. Okay, with the same process, U31 should be 0.2165. Okay, so please try on your own. Make sure you get U31 equals 0.2165. Okay, that is all of the value of U when T is 0.04. And then you will get another 3. Okay, you will get another 3 here for T equals 0.08. So you have these 3 values. Okay, another 3 values that need to be obtained. Okay, so you need to proceed for U12. That is when I should be 1, J should be 1. Okay, so the U12 should be 1.1617, and later you need to get for the U22 by mapping to the Uij plus 1. Here I must be 2, J must be 1. Okay, so make sure you get the value of 0.9811. And lastly, for the U32, I should be 3, J should be 1. Make sure you get U is 0.2255. Okay, so that's how you do the explicit scheme. Okay, the 4 steps here. Alright, I hope you can understand the FTCS scheme. Okay? So later in the next video, we are going to see the implicit scheme, Cry-Nicholson. Okay, that's all for now. Thank you. Bye-bye.